important discussion. And during the break, I think Amrit itself or someone else, they asked me about those videos that I spoke about. All those are getting recorded, but I'm not finding time. It's been very busy these last few days. Hopefully, day after tomorrow, I'll post everything in YouTube and I will send those links to you guys. Initially, I will only post the full videos. Later on, I'll spend some time to cut videos topic wise, like Ohm's law for separate, battery separate video and all. That will become easy when you are near your exams or something like that. All right. So let's complete this particular small topic. We are not going in depth into the battery today, but the fundamentals required to understand battery we are talking about. Okay. So this is the discussion we had before cutting off from the screen. When you drop sodium chloride and try to dissolve it in water, they break into ions. Ions are positive and negative charges. Positive for sodium and chlorine is negative. My question initially was, will they attract with each other? Will they again combine to form a bond? And some of you gave me the answer, they will not, because there is not enough energy to combine. So what I actually proposed is, think of it in a different way. Both of them want to join each other. They want to come close to each other and become sodium chloride again. But there is some other force that is actually stopping them. So we are going to spend the next 1-2 minutes to understand that particular force, guys. Okay. So please focus hard in the next 2 minutes. This is not in your textbook, but maybe the textbook authors feel that you're supposed to know this or something. But anyway, uh, we have two compounds inside, right? When you add sodium chloride, there is sodium chloride, there is also water actually. Okay, so water is H2O. You already know that, H2O. So H2O, the molecule, the structure, you can simplify it something like this. This is oxygen. No, that's not oxygen. Yeah, so this is oxygen atom or oxygen element, that's O. And let's have hydrogen here. So two hydrogens, H2O, right? So it's way smaller, guys. I'm sorry. It's supposed to be a little smaller. This is one hydrogen. And this is another hydrogen. That's water molecule. It's also ionic, if you remember. Water is also ionic, but it also has covalent bonds. And between one water molecule and another water molecule, there are hydrogen bonds. So these are positively charged. H plus, and oxygen has two negative, O minus 2, right? Yeah, we were using green for negative. Yeah. So this is water. Now imagine there is sodium and there is chlorine, and we used this red color ball or whatever. Imagine that's the sodium ion, and the green color ball or green color marble is the chlorine. Okay, so what's happening over here is this sodium and chlorine, they definitely want to come together. But what's happening over here, this oxygen that you're seeing, it starts to pull this sodium, or another oxygen from a different water molecule will pull this positive, and these hydrogens which are positively charged, they'll pull this negatively charged particle chlorine. Once again, oxygen of this molecule or oxygen at a different location, they will start pulling this sodium ion, and hydrogens of this particular molecule, water molecule, or hydrogens of a different water molecule, they'll pull the chlorine molecule. So essentially, even though these two want to come together, the forces of water, it's not just one water molecule, there are hundreds of water molecules that are doing this thing actually. So when they do this sodium chloride, they never can join back together, because these particular things are pulled apart by these water molecules. Okay, so sodium and chlorine, positive charges move in one direction, chlorine ions or chlorine charged particles, negative charged particles, move in the different direction. So ultimately, if you have electrodes, positive charges. Now, sodium chloride cannot be separated like this. Na and chlorine cannot be done, but you can think of copper sulfate or any other thing. So copper plus 2 ions will move towards one direction. Chlorine or copper sulfate, right? Sulfate ions might move in the other direction. Okay. And the reason this is happening is because of the electrolyte. The electrolyte or the water that's inside that particular beaker, it is actually separating them. This separation is done by the electrolyte, and the force that is required to separate these ions is called the chemical force. This is very important in order to understand the battery. Let me check once the chat window for questions, and then I want to revise this, and then we can close it off for today. Sir, why do oxygen pull? Oxygen is actually, okay, I have question from Hasini. She just asked me, why is oxygen pulling sodium? Because oxygen is relatively negatively charged. Hydrogen is positively charged. I'm talking as relatively. Okay, relative means relative to the other substances, it has positive charge, and oxygen has negative charge. So since it's negative charge, it has this ability to pull the positive sodium ions, and hydrogen, since it's relatively positive charge, it has this ability to pull chlorine. So ultimately what you need to remember is sodium and chlorine, they can't come together because a chemical force is actually given out by this oxygen. A chemical force is given out by this water molecules in the electrolyte, and those are actually separating them. The separation of ions happens because of a chemical force of the electrolyte. This is the most important conclusion we can draw, and that is crucial for understanding what happens inside a battery. So this is the first stage, guys. I'm not going to speak, I just talk about the stages. This is the first stage where there will be chemical force. Second stage, there will be chemical force and electric force on all the ions. Third stage, chemical force and electric force become equal. And last stage, they become equal, and the battery becomes a little stable. So these are the various stages of a battery, and we'll be discussing all these stages tomorrow. And I think it will take for us around the half an hour, and the next 1.5 hours we can focus on the experiments. So before we close, anyone, do you have anything to add, any questions or anything? Why will oxygen pull sodium when it is no? I mean, it's never stable. Imagine if it is stable, it would never dissolve. So I mean, I have Chandrahasa asking me a question. Why is water molecules pulling sodium and chlorine separate? I mean, they're trying to separate sodium and chlorine. They're separating them out because it's not stable, Nana. It's not stable. The same reason water absorbs atmospheric oxygen, atmospheric chlorine. All these things that are inside water, like the plants or the fishes, they survive because of oxygen dissolved in water. Water is able to dissolve oxygen, or it is able to dissolve sodium chloride because it's not completely stable. Still, it's all charged particles. There are a lot of charges still inside there. It's not completely satisfied. Pure covalent bonds only have satisfaction, but which are partially ionic or completely ionic, they never get satisfied. They're ready to dissolve everything. Water is called a universal solvent just because of that reason, because it has these ions inside for oxygen and hydrogen, so it can dissolve anything possible. Okay. Even though we are saying universal, I'm talking about only about ionic compounds. Okay. Now I just got a message from Bhargav that he's going to give a police case for taking 2 hours class. I'm sorry about that, but the thing is, it's about the depth of, I can take 1 hour class, but we might need 15 days or so, guys. I don't have so many days. That's the problem, actually. Okay. Anyway, now let's close this. I don't want new police cases on me. I have already lots of old police cases. Right. So we are closing it off. And let's meet tomorrow. I want to decide on the time. Is 4 o'clock all right for you tomorrow? Because I have few meetings in the morning. Only time I have is 3 o'clock or 4 o'clock. So just let Amir sir know about it, and we can schedule it accordingly. Okay. Everyone, goodbye. I'll meet you tomorrow. Have fun today.